Hello everyone and welcome to Network Playroom. This is the 11th video in the Christmas calendar series, and today we're going to continue with the Spaninng Tree theme. So we've previously discussed how the Spaninng Tree topology is calculated and how you can influence it by manually configuring the root switch, which will be the focal point of the network. And everything in Spaninng Tree is based on the Bridge Protocol Data Unit, or BPDU, and today we're going to look at it in detail. So switches exchange STP information using the BPDU, which is a special frame type that contains several fields which are compared in STP calculation. And there are several different flavors of Spaninng Tree protocol, which we will not get into in this video, but the BPDU frame format varies slightly depending on the type of protocol used. And this video focuses on the standard IEEE BPDU, but I'll mention properties related to the Cisco specific implementation. So let's look at the outline of the BPDU on the screen here. And for the purposes of this video, we'll ignore the frame control and logical link control fields, which have specific preset values. So we'll ignore these fields. Okay, so the destination address contains the Spaninng Tree multicast address. And Cisco actually uses two STP multicast addresses. Number one being, let me write that down here, 0180 C200 and then 0000, which is the IEEE 802.1d standard. And then the other one is 0100 0CCC and then CCCD. So these are the two different destination multicast MAC addresses that Cisco uses with Spaninng Tree protocol. And these different destination multicast addresses are used in different situations, which we'll not examine in detail in this video. That is a topic for another video at another time. And the source address is the MAC address of the individual ports sending the BPDU. So this field here is the MAC address of the sending interface. Sending interface. So this is not the base MAC address of the switch. So it is not the same MAC address that you would see in the bridge ID, but you will see it later once we look at a packet capture. So now let's jump to the actual BPDU, so which is actually this part, the whole thing here. That's quite a few fields. So the protocol identifier and the version fields are always set to 0. So these two. This would be, the value would be in hexadecimal, so it would be like this, and this one like that. And then the message type / BPDU type field identifies two kinds of Spaninng Tree BPDUs. Either the configuration BPDU, which is type 00 in hexadecimal, and the topology change notification BPDU, which is type 80 in hexadecimal. So this field has only two options. So either 00 or 80 for, sorry, this one is for the configuration PPDU, and then this one is for the topology change notification PPDU. Let me do TCN PPDU. Okay. And then the flags field is a 1 byte or 1 bit, sorry, not 1 bit, 8 bits long field, but only 2 of those bits are used to handle topology change events. So the topology change flag and the topology change acknowledgement flag. So yeah, this field is 8 bits, so 1 byte, but only 2 of those bits are used. And there's the topology change flag and then topology change acknowledgement. I'm just going to shorten it with ACK. And then next is the root ID field, which contains the bridge ID of the root switch. So we've looked at this value in the previous videos. So this is the 2 byte priority field plus the 6 byte MAC address. So if you remember, we had something like this. So here's the bridge priority. And actually that had 2 parts. So it had the priority value, which you can configure, and then the extended system ID, which is essentially the VLAN ID, and then the MAC address. So that's what you would have in this field, in the root ID field. And next, there's the root path cost, which indicates the sender's cost to the root switch. So here, in our example, we looked at fast Ethernet interfaces, and the default cost is 19 for 100 meg interfaces. And then next, there is the bridge ID, which represents the bridge ID of the sender. So it's exactly the same as this one, but instead of describing the root switch, it's describing the local switch, the sender. And next up, we have the port ID, which includes the sender's port priority and port number from which the PPDU was sent. And we actually haven't talked about this field yet, but the structure is similar to the bridge priority. So the port ID is formed by a port priority value and an interface identifier, which in total is 16 bits or 2 bytes. And I believe 4 bits are used for the port priority and 12 bits are used for the port number. And the priority can range from 0 to 240 in increments of 16. And normally port ID is denoted in hexadecimal, such as like 8005. No, sorry. I have an example that has 8015, which is actually equivalent to 128.21 in decimal. So the first part is the default priority number and the second part is the switch interface identifier. So by default, the priority is 128. And note that the port number in the port ID is not always consistent with the interface number. So here it says 21, but it doesn't mean that this is FA0/21, for example. And similarly, the port ID for FA0/1 is not necessarily 128.1. And the internal mechanics of iOS choose the port number somehow. I guess it's platform dependent and factors in the module, the slot, the interface, and so on. But the port ID, so the structure is very similar, so it would be something like this. And you would have the port priority, and then the port number. And the default here is 128. And then this part is going to be dot something. In our example, it was 21. Okay, so then let's move on to the timers. So the message age indicates the amount of time since the root switch sent the PBDU. And unlike the 3 other timers we'll discuss shortly, the message age is not a fixed value. So the message age field contains the time that has passed since the root switch initially originated the PBDU. And the root switch sends all its PBDUs with a message age of 0, and all subsequent switches add 1 to the value. So effectively, the message age tells the switch how far it is from the root switch. And of course, the remaining lifetime of a PBDU after being received by a switch is max age minus message age. So root switch starts with 0, and then each switch incremented by 1. So next, there's the max age, which indicates the current when the current PBDU becomes invalid and should be deleted. So each port keeps a copy of the best PBDU it has learned, and if a port no longer receives the PBDUs after the max age time has elapsed, the switch assumes that a topology change must have occurred and the PBDU is aged out and discarded. And the default value for this field is 20 seconds. So if a switch doesn't hear a PBDU in 20 seconds, it reaches the max age timer and it's going to age out the PBDU and throw it out. And then a bunch of other things are going to happen, but we're not gonna get into that right now. Okay, but next there's the hello time. This is pretty self-explanatory, but it indicates how often PBDUs are sent. And this is 2 seconds by default. And finally, there's the forward delay value, which indicates the time a switch should wait before transitioning to a new state after a topology change. And this is 15 seconds by default. The forward delay timer is used in other situations as well, but again, I don't want to get into that in this video, otherwise it's going to be so long and complicated. By the way, the STP timer values always reflect the timer settings on the root switch. So timers configured on a non-root switch are not used and would become effective only if the switch itself became the root switch. So these 3 fields here are dictated by the root switch. Okay, but now that we have an understanding of the PBDU fields, let's think about what the PBDU for a specific switch would look like. So I'm going to use a diagram that I've shown you in previous Christmas calendar videos when I introduced Spanning Tree protocol. So let me actually get rid of all this mess. And then let me hide the BPDU. And then let's look at this topology. And actually we'll look at a real packet capture after this. But the packet capture is unrelated to the topology. So let me open up this show spanning tree information as well. So let's look at switch B over here. You can see here is the MAC address, which is also listed over here. And then this is the root switch. And that is information is presented here. Okay, so keep that topology in mind. And here we have the show spanning tree output. So now that you've seen that, let me close that and open the BPDU and we can start filling up the information. Let's not focus on this right now. Start from here. And let's think about what would be in these fields if we were to look at a packet capture from that topology. So first of all, this would be the root ID. And actually this included the priority and the MAC address of the root switch. And then the root path cost would be 19. And then the bridge ID, similarly, it's going to be this section. So we're looking at this field now. And then here you can see the port ID. Like that. So as you can see here, these actually match. So FA0/1 has a port ID of 128.1. So this is kind of matching here. This is not always the case. And then finally, we can find the timers apart from the message age. We can't see in this output. We don't know where it is. But here you can see the hello time is 2 seconds. Max age is 20 seconds. Forward delay is 15 seconds. Actually, I'm not sure what this aging time here is. That's a good question. Maybe one of these is from the root switch and one of them is local. I don't know. If someone knows the answer, please leave it in the comments. Okay, but that is what a BPDU for switch B would look like. So now let's jump to the real packet capture. And just to remind you, the packet capture is unrelated to this topology that we just looked at. This is completely hypothetical. This is a theoretical example. But let's go over to packetlive.net and look at an 802.1d spanning tree packet capture. So let's open up the first packet and expand the spanning tree protocol part. And actually, before we look at that more carefully, let's pay attention to the source and destination addresses. So the source address is the MAC address of the interface who sent the BPDU. And again, note that it is not the switch base MAC address. So here you can see the source MAC address. And note here that the destination is the well-known standard spanning tree MAC address. this one. And why is it the standard address when there is a Cisco specific one? Well, this is not entirely clear to me because I assume that this packet capture was taken from a Cisco environment with Cisco specific per VLAN spanning tree running, but I believe it has to do with the interface configuration, maybe, because access ports send only standard IEEE BPDUs relevant to their access VLAN, and trunk ports always send a set of PPDUs, the standard IEEE BPDU and the Cisco per VLAN spanning tree PPDU, which is untagged for the native VLAN and tagged for all others. But anyway, this is the standard IEEE BPDU destination MAC address. But now let's focus on the spanning tree part. So as I mentioned, these two fields are set to 0, and this is a configuration PPDU. You don't have to worry about the type too much. We haven't discussed the different types and what situations they are used in. And the same with the flags, but just to show you that here you have the topology change acknowledgement and the topology change bits, and both of them are set to 0 right now. And then we have information about the root switch. So here you can actually see a nice breakdown. So here's the priority value, which is the default, so 32,768. You've heard that so many times in other videos. And then the system ID extension indicates 1, so this is VLAN 1. And here's the base MAC address of the switch now. So notice how these two values are different. So let me open this up again. So notice here, this is like ends in 85, and this one ends in 80. So they are different. Okay, moving on. So the root path cost is 0. Now what does this mean? How can it be 0? Well, it's because the root switch itself is generating this PPDU. And there's a few indicators about this being 1. But when we go further, you can see the bridge identifier is equal to the root identifier. So you can see they have the same MAC address. So that's another indicator that this PPDU is generated by the root switch. And next, you can see the port identifier in hexadecimal format. So in decimal, that will be 128.5, I believe. And also this one is a third indicator that this PPDU is generated by the root switch because the message age is 0. So remember that the root switch sets the message age and it's incremented by 1 at each switch. And here are also the default values for the timers. So max age 20 seconds, hello time 2 seconds, and then forward delay 15 seconds. But yeah, that's what the PPDU looks like. And as I've mentioned, that is at the core of Spaninng Tree protocol, and everything is based on the PPDU or the exchange of PPDUs in a switched network. And there is no other message format. You know, like in some routing protocols, you can have several different packet types. In Spaninng Tree, you have only one, and it is the PPDU. You do have those flags to distinguish the different kinds of PPDUs, but that's it. So I hope you found this video informative. Thank you for watching, and I'll see you in the next video.